Folks, let's get going. Welcome everyone. So, anybody want to give an update on what they've been up to, or issues, or submissions, or scores?
I managed to work a little bit on the series network, so I can show what I did. The score is not that great though, but at least some progress.
Great, go ahead.
Okay, let me share my screen. So as I mentioned last time, you see my screen, yeah?
It's coming up.
Okay.
Yep, at least I can see it now.
Okay, so as I said last week, basically this whole Siamese thing looked to me somewhat similar to what you have been doing with the Lstm. So what I did is I just took your workbook and then just made a small changes, so I can show you those small changes, and then I start submitting. So those changes were actually in the model itself, which is here. Yeah. So in here, as usual, I have the embedding layer. I did try with the Lstm, did try with BiLSTM, did try with the GRU, but the best score I'm getting is with the Lstm. With the BiLSTM, the training gets very slow, but then again the results start. If you go look on my left hand side, as I start experimenting, like start doing these guys, they start going up. For example, here the GRU score is this, BiLSTM is even worse. With the simple Lstm, the score is good. And the only difference is that this is same, your left output and right out, sorry, the input, the left input and right input is same. The only thing what we did was the Manhattan distance between the two vectors calculated in here. So that's the only difference between the simple Lstm and then Siamese. And again, any of you can correct me if I have done right or wrong, because I'm not too much aware of Siamese. This is what I thought is, my reading says that this is what the Siamese is all about. However, one more changes which I try to experiment was with the way we are stacking things. So I'll show you here. Yeah. So we usually stack this question 1 and question 2. I think, just give me a second. Yeah, so if these are like a different experiments, that's why I have the commented out. We usually do Q1 and stack over a Q2, and then Q2 was the Q2 and Q1. So this is what we've been doing. And I try to experiment keeping Q1 and Q2 same, in a sense, on the left side, you will have a Q1 and below Q2, and on a Q2 training the same, so that on the network, two different questions, it's the same set of question will go on a 2 Lstm and then do the comparison. However, that didn't make much difference either. The definitions are not coming in here. If I hover my mouse over, let me see if I can. Yeah, if you read it, it reads, if you read this definition, it says QQP model Siamese BiLSTM with the questions looking face to face. Face to face means Q1 training have one set which is left. It has a Q1 question 1, below it question 2, and then right input is again the same, Q1, and then below is Q2. However, that's the experiment I did. However, it didn't make much difference. The best score is still same, which you and John did. The simple LSTM, and I haven't used the leaky feature yet. So, and again, I was trying. I have tried the instead of a binary cross entropy, I tried MSC to see if it gives me some good results. I think there must be one of them. Let me see. One of the mistake I did is not clearly giving the, for every experiment, I forgot some time to give a good definition so that it appears here. So some of them are off as well. However, I tried the MSC as well. That didn't work out well. Plus, I tried to use NADM rather than an ADAM optimizer. Again, that didn't make any difference as far as training is concerned as well. So all in all, that's what I did. The best score was, this is the score which I received with simple LSTM, no Siamese. Just don't go on this. This was simple as LSTM. At that time around, I didn't do any change. So without leaky feature, simple LSTM, that's what I was getting. And then these all are different loss functions, different optimizer, different way of putting question 1 and question 2. However, it didn't improve. And this is the best result about the Siamese, where I have, if I hover my question here, it says, if you read the definition, it says questions looking across. Question looking across means the left side is Q1, question 1, and below it, question 2. And then on right hand input is question 2, below it, it's question 1 stacked. It going there, using them, and then using a Manhattan distance to see the difference between the two. That's the best result I got. However, this result is without the leaky feature. So now I come to this point that now I think I start using it to see if that makes any difference whatsoever. That's all I have. Any question?
When you say Q1, what's, in the stacking, what was the difference? You said Q1 and under the Q1, Q2 first, and then what we had done so far was to flip and put Q2, Q1
Yeah.
underneath that, right? And
Yeah.
you're saying you do Q1, Q2, and then again Q1, Q2?
That's correct, yeah. So the Siamese network is supposed to, you have a left input and a right input, which is like two same images or same set of input goes in, and then it supposedly it's try to distinguish if there is any difference between two. That's what it's supposed to do. So that's again, like that was my thinking. So I thought, okay, maybe if I send two inputs exactly the same, if it can distinguish between two, it learns something and then come back. That's what I try to do. Yeah, so this is the one. Yeah, it didn't make any difference though. And now what I like to do, what I was getting into is, instead of stacking the question 1 and question 2, I was trying to do just have a question 1 only on the left hand side and a question 2 on the right hand side. So no stacking whatsoever. That's the experiment I like to do again as well. So without stacking, if I just send two questions in parallel to see if it can distinguish any difference between the two. This experiment hasn't completed yet, though.
Interesting.
Hi, Dinesh. So just a more basic question. So let's say, so Siamese network, you have different pairs, right? Like, so what's the intuition like? Like, it's not all question pairs about weather, right? It's not grouped by category. It's like, okay, some question pairs can be about weather, some question pairs can be about sports, or some can be about cooking.
Yeah.
So does it, so the intuition is somehow it is able to learn even if the like the category of the questions is very different, the network is still able to learn the similarity between the two questions.
That's correct. So I think the idea is that we are going to have this like in a high dimensional space. The Manhattan distance is the good one to like find out how close they are. So that's supposedly the I mean, I think there are maybe perhaps there are different aspect of it, but I just picked this one from a blog where he explained that when we calculate Manhattan distance between the two questions, that's good enough to find out the similarity between the two. But I am not sure about the category it looks into, perhaps because it's a one big vector, so whichever category it belongs to, again, like I have a distinguishing here, it's the glove vector 100, which is I'm using a glove vector 100. I tried with a 300, but the result were worse, so I just kept it on 100 as well. But I haven't done that sort of any categorization between the question whatsoever. No, it's very simple. It's like a cosine difference between the two we did before when we started it. Here we just doing this the Manhattan distance.
Okay, thank you.
Okay, anyone else want to provide update or share?
Yeah, I can talk.
Go ahead, Gautam.
Okay. Just sharing. You guys can see, right?
Yeah.
Yep.
Okay. Just a minute. My laptop just froze. Okay. I'll just close Slack. Okay. So I have not solved my problem yet. The problem of low validation loss and high test loss, but I have found out where the discrepancy is exactly. So it's not class weight because like as soon as you go to inference time, your class weight does not matter anymore, right? It's just the model doing predictions on data. It won't matter too much, as if your model is performing well on a validation set, then as long as your test is not too different, I think it should not matter too much. And so yeah, that was not the problem.
That weight will not be used because you're not calculating loss.
Yeah, exactly. Yeah, it doesn't matter in inference time.
But
Yeah.
did you find out whether it's 0.58? That's the because in
1.7 did not work better. I mean, it was bad actually.
But the question I had was more: is this the way of supplying the value, or I mean, what? because I was using TensorFlow. In TensorFlow, it seems, at least from the notebooks I saw, it's given as a dict, so you supply both, and that's therefore very clear. Here, when I looked at the PyTorch documentation, it seemed to give an example when I looked at the binary cross entropy loss. Then it gave an example of 100 positive and 200 negative, and because the ratio is obviously 1:2, it then said give the and I'm talking from memory, so my numbers may be wrong, but it seemed to say you need to give it 2 to 1, or the 3 to 1 rather than the 1:2, depending on. So we can look at that, and that's what confused me about what you were supplying here versus what the binary cross entropy documentation said needed to be supplied. So that's what I wanted to get clear of. Is that at least I know Rekil has used the weights before in PyTorch, so was wondering what's the correct methodology for supplying that in PyTorch.
Yeah, I did look at a few examples of people using it, and what they have done is like assuming that the weights add up to 1, and how much extra weight do you want to give to the positive class. So I want to give slightly more weight to the positive class, which is 0.58. So the other class would be 0.42. This is what I saw from some Stack Overflow answers, and this actually improved my
Sure.
validation scores. Yeah. Yeah.
What
And
is
yeah.
what
Yeah.
was the difference from before though, Gautam? I'm just kind of confused. Like, what are the two things that we are talking about, like one versus the other? Whether we should pass it as ratios, or is
Yeah,
that
see, so here was the confusion why I might have sent Gautam on a goose chase. But at least when I looked at the documentation, so when you look at the notebook I had, and also Steve used, it was on TensorFlow. So there it provides both the 0 and the 1 value. So you just say, class weight 0 : and then 1 : right? So you're explicit. Whereas in case of the binary cross entropy loss, or was it the NN log loss? I forget which one. They had an example for in PyTorch, and that one seemed to give a different way. And I know you had mentioned weights before, Rekil. So I was curious as to what's the proper way to supply, because again, in my mind, the ratio of 1s to 0s is low, correct, in our data. So I thought what we want to do is increase the number of 1s, is what we are trying to do. Therefore, the value we should supply, or that Gautam would be supplying, would be 1 by 0.58,
I
which would
think
be 1.7. But
that
that's what confused me.
yeah, I have to look at the docs myself. I'm also not very sure, but I think the sampling part is like when you're trying to make your data loader, there you want an equal balance of both ones and zeros. So if ones is lower, you want to sample at a higher frequency there, right? That
Right.
makes sense theoretically.
Yeah. So which would mean that you wouldn't, but
But that's
then,
what I don't know. I don't know what PyTorch is expecting. Do you need to supply the frequency or just the weight, and then it probably does the inverse by itself? So
yes,
that could be
exactly.
a
That's what
possibility.
confused me. Or at least I wasn't sure. It's made kind of very obvious in TensorFlow because it gives a dict with 0 and 1 value. So that's very simple, right? You're specifying both, so you're very clear.
Here you're
But
not specifying for all of them?
here, see, for example, he just used 0.58, right?
Oh, okay. So that's why Gautam is saying, okay, this automatically calculates the sum is equal to 1.
Yeah, and
Okay.
that's where I wasn't sure whether it was 0.58 or the inverse of 0.58.
Okay.
Yeah,
because
it's like
0.58 is the
1
ratio,
2 as
if I
well.
remember, correct me, Gautam, but it's the ratio of ones to the or
It's
zeros
zeros
to
to
one.
ones. Yeah, it's
Yeah.
zeros to ones. And that would be the weight of ones. Like the ratio of zeros to ones will become the weight of ones. Because zeros
That's
is since so this is the number of okay, where did that
yeah,
go?
you got it right
So
there.
since zero is more than ones, the ratio of zeros to ones will be bigger than the ratio of ones to zeros, right? And that big number will be the weight of ones. The larger weight will go to the
Smaller. In that
yeah,
sense.
yeah.
Yeah.
Okay.
Now, if I may, since Gautam, if I can share the point or the doc,
Okay.
or maybe I can even for a minute, then
Yeah.
because I'd like to put this to bed because it's an important thing I wanted to get clear in my head. Let me see whether I can go to the bookmarks. Yes. Okay. Can you folks see my screen yet? Hasn't come up, but
Yep.
okay, just a sec. Look at this. This one. Sorry about that. My driver is really slow. This is the same. I think 10. This is where there. Okay, so here's the example that so here's the example that they're using. And again, keep in mind that this is for BCE with Legit's loss, which I thought was what we were using, Gautam, but correct me if I'm wrong. But this is the one that I looked at. So it says, for example, if a data set contains 100 positive, and 300 negatives, then POS weight for the class should be equal to 300 by 100, that is 3.
Yeah, this is
When it's
exactly what I'm
100,
doing, right?
sorry,
This is exactly what I did. So the ratios of zeros to ones became my class weight, which is 0.58.
so zeros to one. So the negative example is in this case
Yep.
zeros. So zeros and the positive example is the ones.
Yep.
So you took the zeros to 1. Okay,
Yeah.
got
It's
it.
the same thing.
Thanks.
Yeah.
Okay, cool. Let me stop sharing. Okay, that clears it up. Thanks.
Okay. Okay, so the main thing I wanted to show was, so I just ran it for 2 epochs and it gave me these results. Valid loss 0.36 and 0.743. This looks fine. Then I submit as usual, and I mean, obviously it will give me some horrible result. But then what I did was, so I have this predict function to predict on the uh, test set, right? So I figured something. So I figured if I can run my validation through this, and then then I can check if I'm getting the same accuracy that I got here, then I can just rule out something being wrong with my method, right? So I did just that. I uh, so I wrote another predict new function, which is the same thing. So I passed my validation set through my predict function, and uh, yeah, I then calculated accuracy manually, and I got a horrible accuracy 0.58. So what I got in this training loop is 0.743, and when I use my predict function to uh, predict function on my valid set, I'm getting an accuracy of 0.58. So yeah, this is where my problem is, and I'm not able to uh, exactly figure out where the problem is. But I think I can. I mean, this shouldn't take too much time for me. But from what I've seen, nothing seems to be really wrong in the way I'm calculating accuracy. I'll quickly go through that as well. So what I'm doing here is in my eval function, I have an accuracy function. This thing I have checked it. It works. I mean, it's works the way it's supposed to. So it takes logits and labels, and then it takes sigmoid of the logits, and then it rounds it. So round is basically greater than 0.5 is 1 and less than 0.50, and then prediction is equal to label divided sum of that divided by the number of rows. So this function works as expected. I have tested it. Then what I do here is uh, I calculate the accuracy on the batch. So for each batch, I calculate the accuracy, and then I add it to a number called epoch valid accuracy. I add that number, and then finally I divide it by the length of the data loader. So basically the number of batches. So the sum of all accuracies divided by the number of batches. This does this seem wrong to any of you? I think it's right?
Sorry, when you say number of batches, shouldn't it be number of samples in the batch? Like,
So batch accuracy is the accuracy for, say, the first batch, the second batch, and so on, right?
okay.
And I'm adding all of them to this number, to this variable epoch valid
Oh,
accuracy. So I'll have to
oh, I
divide
see.
by the number of batches, right?
I see. I see. Okay.
Right, number of batches if number of samples is like perfectly divisible by number of batches,
Yeah,
right? Because you could have that last
yeah,
weird batch. I don't know how much of a difference that would make.
yeah. That should not make too much of a
True.
difference.
It's
Actually,
just
yeah.
a one
But
additional epoch, right? At most.
Right, yeah.
Even there, wouldn't it count as unless you drop it? Yeah, it's only a plus or minus one difference anyway.
yeah,
Otherwise, yeah, that looks right.
yeah, this looks fine to me as well. Mm, yeah, and yeah, so I was not able to find out why this problem is there, and this is what my predict function looks like. So you can ignore these lengths for now. So I pass in question 1 and question 2 to the model, and then the model does not do sigmoid, right? So I have to manually add a sigmoid on to the predictions, and then I return those predictions, which I then append to the CSV and that stuff. Yeah. So this thing also seems right to me. But then when I pass my valid to this, and then I calculate my accuracy manually, which is what I did, greater than 0.5, I'm getting this accuracy. So yeah, this is where I'm stuck right now, but I think this I can.
But for the same data, you said when you actually run it through your training, you're getting something like 0.74, whereas with
this is
this
the valid
approach, you're
accuracy.
seeing.
This is the valid accuracy after the second epoch.
Right.
And then I take that same data and pass it to through my predict function, and I calculate the accuracy manually. I'm getting 58. So I found out the problem. Yeah, I just have to diagnose it now.
I don't get the part about maybe a miss in your predict function where you had to add the sigmoid.
Yeah.
Because
Okay. So.
yeah, normally you know like I you know I trained a model and then I have the same thing but just with images. Then I just predict, right? That's it. And then the model is already ready. Like it's supposed to do everything unless there's something in NLP I miss. Like you know, like why add the sigmoid there?
So this is a PyTorch thing. So PyTorch, either you can. So here I don't have a sigmoid layer at the end. I just have a linear with the last layer having a single neuron. I don't have a sigmoid after that.
I see.
And while calculating the loss, it does the sigmoid thing by itself. So this BCE with logits loss, it
Oh, I
basically
see.
calculates the loss on your logits,
I see.
not on your, yeah, the sigmoid part it does by itself.
I see.
So if you want to, yeah.
Maybe we can see, is it possible to see the code for that BCE with logits loss? Maybe they're doing something funky or, you know.
Yeah,
Yeah,
that's
but
just the one that we were on the documentation for. You can just pull
Okay,
up.
okay, right.
Yeah. Yeah, and I've used this like a few times before as well. I've not faced an issue like this.
Right, you
I
either
see.
put it in your model or yeah, you just use the logits for your loss.
Okay.
Yeah.
That looks right, I think. Yeah, PyTorch. I don't know, is it something weird like order of questions, something just messing up there? Could be somewhere as low as that. So interesting bug.
So, sorry, if you go back to your training predictions for a minute.
You can ignore these lengths thing.
Yeah.
I'm not
That
using it anymore.
doesn't. Yeah. Not. Nothing obvious that. Stands out. It seems like that should match if you're providing the same data. Yeah, that's a puzzle. Why it isn't?
Let's scroll down to eval. Yeah.
So there is an option to like ignore the last batch, right? In case the last batch
Yeah,
happens to
drop.
be really small. Okay, maybe I'll try that.
Well, actually, in FastAI, do we know? I don't know off the top of my head whether it's there in
Should be there. Yeah, I've
yeah
seen it.
PyTorch. Yeah,
Or you just divide on the fly instead of dividing at the end. I think that's the other option people do. So then every time you calculate basically length of each batch and you just divide by that.
I'm actually trying that. I was trying that before this call.
Okay.
Yeah. Uh,
It probably looks like it's something else.
so I did that as well. So here, what I'm doing is, uh,
I have a quick question actually before that.
Yeah.
Like with probabilities, I don't remember for accuracy, it's greater than equal to 0.5 or greater than 0.5?
I mean that's greater than equal to, I guess. I mean, why does that matter? Unless it's exactly 0.5, it's not gonna matter, right?
True, yeah, correct. Only if you get exactly something as 0.5.
yeah. It would vary the cases only by the what Gautam said of exactly equal to. Then it
Odds,
may
yeah.
lose it, but otherwise it won't.
Um, right, yeah. Yeah, go ahead, sorry.
Yeah, I was just trying out the exact thing you're saying. So each prediction that the model gives me, I'm doing a sigmoid on that, and then round on that, and then I'm making it a list and appending it to a huge list. So all the predictions of the entire epoch will get appended to this list, and similarly all targets also get appended to another list, and then I'm using the good old metrics.accuracy from sklearn
Uh,
uh, to find out my accuracy, and even that gives me 72. So now
oh,
my suspicion
okay.
is something is wrong with the predict.
Predict one. Oh, okay,
Yeah,
okay.
I had to check this once again, but this is what that gave me. Yeah, with the sklearn metrics
Mm-hmm.
appending all the predictions and targets, I'm still getting 72, and yeah, the problem is still there. Something is wrong with this, I guess. Yep.
Yeah, using that extend thing, if you try with your predict, and then you should see what happens there.
Yeah, I should do that. Yeah, I can compare the logits and yeah,
Good.
By
the
the way,
prediction.
I don't. I'm just haven't thought through. Is your batch size the same for the two for training and test,
Yes.
or are you
Uh,
changing? In which case, the length of the data loader, is it the same or is it different? I guess
uh,
when you do.
that shouldn't matter, right? Like,
That's what I haven't thought through whether it should or shouldn't. That's
no,
why I
like
asked.
it should not matter.
Because in
But I
each
am
case
using.
you're dividing by whatever you define as the batch size for that, for train or for test, correct?
Can you repeat that?
I was saying in each case, if you divide by the appropriate batch size, then it doesn't matter, right? Even if you change it, you're dividing by the correct batch size
Yeah.
for train and the correct batch size for test, then it
Yeah.
wouldn't matter.
Yeah. It's actually the number of batches, dividing by the number of batches.
Right.
So that
But the
will make a
number would
difference,
change
right?
depending on your
Yeah,
batch
would
size.
change accordingly.
So
Yeah.
yeah, but as long as you do the right number for train and for test and it changes, then
Yes.
that
Yeah.
shouldn't matter. Right?
Yep.
think I don't know how easy it is to. So one tool, for debugging I came across just like 2 weeks ago is you can take your code and put it in Microsoft, Visual Studio, and then it has this option that at any line, like in your eval function, you can put a breakpoint.
Yeah, I've done
And
that.
oh, you did that?
So,
Okay.
yeah, it's import PD. You don't need you don't even need that. So all you have to do is
Import PDB here.
yeah, import PDB and pdb.set_trace. Yeah, and you can access any variable at that point of time.
Okay.
Yep.
Hmm.
And there was some confusion here, right, Srinivas?
Yeah, actually, if you can go ahead, it would be interesting to now. I'm thoroughly. Go ahead. You may want to ask, or I can. So here's my question. It may be dumb, and I will just go Uh, is see when you do self dot as Gautam is doing, your self dot rnn1 is this layer is defined right now. My understanding is this layer comes because it's an LSTM layer. You initialize its weight matrix using Glorot initialization. Now we come down and to this point, and we do self.rnn1 of embedded Q1. So in this instance, you get the LSTM layer and you get the Glorot initialized values for the RNN1, blah, blah, blah. You run through the code and you generate the output Q1, right? The
No,
question,
actually,
sorry, go ahead. Yeah,
okay. So here is where the initialization and the Gloro stuff happens.
correct.
And here what happens is you are calling the forward method of LSTM. So this gets passed to the forward method of LSTM. Here it's the actual forward propagation of the LSTM layer here
Correct.
and here.
Right.
So the initialization happens just once, which is at this step.
Correct. But my question, just so
Okay.
I'm clear in my head, is that when you invoke, when you run the self.rnn1 to generate the outputs Q2, right? You get the freshly initialized LSTM layer with the Glorot initialization for outputs Q2 as well.
It's the same layer and the weights have not changed yet. So
Yeah, so
whatever
you do get the
question one
same.
saw, the same thing question two will see.
Yeah, that's all I was making sure that, because here, as you said, it is within forward. I forget now in TensorFlow how that thing is, but yeah, the code is
I think it's
similar because
called in TensorFlow.
we both refer to the same layer, and then I just was thinking through to see that you get the Glorot initialized values in order to generate both output Q1 as well as for output Q2, which happens.
Yeah.
Right. Yeah. So that's.
Yeah. And I think probably this is the same thing that Dinesh and even I think your notebook was doing, right? It's
Yeah.
the same
Yes.
layer. Yeah.
Yeah. It's a layer is the same. I was just confused about whether using it this way results in, but at least in my mind, uh, what I wasn't, because this is the problem when you switch frameworks and stuff on the fly, was, as you just explained, I didn't pay attention to the forward in the way I had used, or at least the notebook I had used uh, in TensorFlow. It was just either in sequential, or I have to go back and look at it, but it wasn't within the forward. So that kind of threw me a little bit.
Okay.
But
Okay.
yes, now we are on the same page.
Yep. That's all I had, I think. Yeah.
Okay. Steve, anybody else? Steve, you want to share anything?
Not this week, sorry. I'm afraid I haven't had a
Huh?
chance to to submit anything this week, so yeah, I'm playing catch up.
How about anyone else? If not, I can share some of what I had, and then just like Gautam's case, I had a mystery of the leaky thing that I was trying to figure out, and maybe collectively we can figure it out. But anyone else before I jump to sharing kind of the ablation results from my notebooks? Okay, if not, let me try and share my screen. This is the interest of, we talked about the various ablation studies to perform that would be interesting. As I mentioned last time, I had done the thing with a bunch of CNNs, as you saw in the notebook. If you were there last week, and also a bunch of, and also the Lstm approach. And then last week I had only submitted one run, and as Gautam was saying, I was running it just before, so I just had a single result. This week I wanted to kind of share with you the ablations, or all the different combinations that I ran. So let's go over that for the convolutional, or the notebook that uses the convolutional layers. If you remember, it was the con 1D, 2D, 3D until 6D. And the best results I had was using leaks and using early stopping. And obviously, I mean, shuffle is always on for everything, but anyways, I just listed it. So shuffle, leaks, and early stopping. ES is early stopping. And I got the results of the best score of 0.170 and 0.172, right? So that's the combination with the leaks and with early stopping. Now, if you just did the early stopping with no leaks, now let me go back to the baseline. The baseline was where my leak wasn't working, and I didn't use early stopping either. And that gave me kind of, fairly poor results, 0.47 and 48. Then if I added leaks, but I did not do early stopping, and keep in mind that this is the convolutional network that I'm using, then it did drop. You can see from 0.47 to 0.317, and then 0.48 to 0.32 on the private score, right? So it did get better than baseline. And the interesting thing, because I had combined both, and what Rekil had asked and multiple people had questioned was, how much does each of this, how much does leaks contribute, and how much does early stopping contribute? So I flipped this to no leak and just did the early stopping. And that gave about, you can see again, equivalent kind of almost plus minus, but it gave a little better result actually than the leaks, right? In both cases, public and private. So it seems, at least in this case, marginally early stopping seems to help more than does the leaks. Both are of the same order though. At least for the convolutional network, which seems to say that the convolutional network, and I'll get to the LSTMs in a minute, are kind of overfitting, and therefore early stopping does help, and help quite a bit, almost as much as the leak does. Actually, more than the leak does, slightly than the leaks do, I should say. And then obviously, when you combine it, you can see what the result is. Any questions or thoughts, comments on that?
For early stoppings, how many epochs you're using?
It automatically stops, right? Early stopping means it stops automatically. I think patience is 10 if you check in the notebook.
Yeah.
I'll repost the notebook, but so it means, and then I saw it stop. Again, it depends, but it stops somewhere in the 15, 17, in that kind of a range. And I give it, 30 to 100, 100, whatever. It doesn't matter, because it's going to stop as soon as it doesn't improve. Right.
Okay.
So
I have given patients like just under 5 because I wanted to stop it early. and a couple of times I tried. It went on to 80 epochs. So your validation score would go down, but it would go very marginally. So interestingly, like the score was not going down. However, then your training will just keep going. So I had a few runs which went on up to 80 epochs, and then it finished. So that was that's the reason I was asking.
Yeah, no, in this case, it overfits and begins, actually the validation score begins to go up, so it stops. So that's what I see with the CNN. I kind of repeated the same with LSTM. And here the results are slightly different, which in itself is also interesting. And it gave me an idea that I saw referred to elsewhere, but I haven't tried it yet. But LSTM model, so again, same thing. The best results are below, which combines leak and early stopping. So 0.18 and 0.18, slightly worse actually if you see than the CNN model. And then the baseline, it actually gave a better results if you see than the convolutional network models. And the baseline is with no leaks and no early stopping. And in this case, I believe I think because it takes quite a while, I stopped it at 30 epochs. So this one runs for 30 epochs. I believe in this case, again, since there's no early stopping, I stopped it at 30 epochs as well, I think. So it gave this result, but you can see that the baseline is actually better, even though the best results are somewhat worse. And then, without using leak and just using early stopping, it changes a little bit. But early stopping in this case didn't seem to make too much of a difference, because unlike here, it didn't overfit. So it didn't really, it went on, I would say, even with early stopping, it went on to like 28 epochs. Right. So in that sense, it seems like the LSTM doesn't overfit as much as the convolutional networks does. And then, so the validation error doesn't go up until it gets close to the 30 epochs that I was anyway limiting it to. And then no early stopping, but using leaks, it had a much more of a significant impact. So you can see that from 0.32, it dropped to 0.21. So then when you combine that, the early stopping contribution obviously is a lot less for the LSTM, and the leaks contribution is much more significant, which I thought was interesting. That in case of LSTM, it doesn't overfit, so the leaks matter more. Early stopping doesn't. Convolutional networks overfit, so the leaks matter as much as do, or stated otherwise, early stopping matters as much as does the leaks.
What's the shuffle you have there?
That's just that the shuffle switch is on for the data, right? I mean, when you train, you're shuffling.
During training, or shuffle is going to true. So what does it do? It's shuffle the data during each epoch.
Yep.
Okay. So that's just to avoid any overfitting. Is that correct?
Yeah, it helps in not having the same order for each, not going through the data sequentially, right?
Okay.
It randomly picks from the training data rather than going through. So any sequentiality effects are avoided by shuffling.
All right.
Any questions or comments from anyone? Any interesting thoughts or come to mind based on this
We checked the
result.
number of parameters last time and they had the same number-ish, right?
Yeah, actually, the thing I was surprised was depending on, and because I kept modifying, I don't think I have the right figures in there right now, but the order of magnitude was about the same when we looked at it last time. Yeah. For both of these. One was 35, the other was 37 or something.
Yeah, interesting.
Right. So that's that. If anybody, if no one has any further comments, something I wanted to share, which I misspoke last time, and I wanted to clarify, and then there's still a mystery I'm in chase of. So let me share. Okay, again, my driver problem, but can you folks see my screen yet?
We can see.
Okay. So what one thing I wanted to clarify with respect to these leaky features that Steve helped us figure out, or at least get it working, is the following, right? I had said, so what I misspoke or was wrong about last time was these are actual full sentences. These are not words. So let me, for example, so what I did was, so what it does, again, to remind or reorient everybody, because over the week we forget or all busy with other stuff. So here you're just concatenating the question one, question two, of the train, and then of the test, resetting the index, basically making them all a sequence, and then building a dict. A default dict essentially means that the elements within the dict are sets, and also you wouldn't get a key error if it comes up empty. It'll just give you an empty set. So that's all that passing in a set to and making a q dict default dict does. And then you do this, which is to the question 1i of this questions, which is nothing but a concatenated data frame of question one, question two. You're adding, you do dot add because each of the entries in it will be a set. So you use a set command of dot add questions on question 2i. Okay. And then you go back and flip it around by doing qdict question dot question 2i, and then you add question dot question 1i. So I wanted to kind of figure out what last time we had talked about it, of at least take a look at the dict and take a look also at what. Now the other thing to orient ourselves also is the fact that here we are doing the qdict on row, but this row that we are using, because it's actually on the df train. So for every row of the df train data frame, you apply, and let's start with the simpler one, q1 frequency, which means you take the row of df train, the first row, pass it into this. That's what row of question one will become. And then the qdict that you have built for the question one of df train apply, you find the length. Okay. And that's what you stick in the q1 frequency column. And similarly, you stick in the same, but with for the column question 2 in the Q2 frequency. So, and then Q1, Q2 intersection is you do this, you take the DF trains row, each row, whatever row it is, let's say the first row, then first row's question 1, whatever the QDict is of that, take the set and its intersection with the QDict row question 2. So, you know, I just want, now the real thing I'm after is trying to actually explain to myself what these values convey, or what does this length mean? Okay, I still haven't totally figured it out, but I'm in the process. If somebody already knows it, or based on the code, or as we go through, if you can explain, then that'd be great. But I am just figuring it out. So as I mentioned, the thing I wanted to clarify is you can see this is just printing out the question 1, question 2 from questions, that data frame that's being built. Okay, so that is just, I'm just printing the head 3 values from the questions data frame. That's all this thing is, the first 3. Okay, the next, which is the interesting one, is this dict. So this dict is the, as you can see, it's a dict. Unfortunately, it's also the dict has sets as values, which also have these curly brackets, so it makes it a little bit confusing. But the important thing, as I wanted to highlight, is this is the entire sentence. So this entire Q1, right? So question 1, it just takes this, and then in the dict, it sticks what's the step-by-step guide to invest in share market, which is this guy, right? And then, so what I was trying to print was just 3 items by slicing the qdict.items. So now this very gets annoying in terms of what I need to do to scroll, but so this is the first one, and then it builds the what is the step-by-step guide, because remember that qdict then will go to the next say like qdict, because it right after it's added this, it does for the question 2i. So since I is still 0, it will take the second question and stick in the first question 1 as a entry into the dict, right? Now, what's interesting, and this is something I wanted to do manually to get an idea, is what happens, you can think through, if these 2 questions are identical. If it is, then this key and this key would be the same, right? Does that make sense? Or am I off in la la land?
Yeah, that's the whole point of a dictionary. So if question 1 and question 2 are the same, it'll only add 1 entry into the dictionary for that key.
Right.
So like that's why it's using the default dictionary as well. Yeah, like in case there isn't a key or whatever. But
right.
Yeah, so if the 2 of them are the same, you should only get 1 entry.
Yeah. But then, see, I still don't get what it's trying to do with Q1 frequency, meaning what's this length indicate? Because I'll show you what ends up happening. It seems to do how many of questions in a vertical sense, meaning how many of the same questions recur in this row, in the rows, and how many entries do they have as dict entries. That's what it seems to figure out by Q1 frequency. And right, because if you look at now if I keep going, you can see that Q1 frequency, Q2 frequency, and Q1 frequency of like this row is 8. So does this mean that there are 8 entries in the dict for, and I'm kind of making it up as I go, meaning I'm thinking through this, but for this particular entry, meaning what is the story of Kohinoor diamond, let's say it's that, then there are 8 that it appears, or sorry, yeah, it appears 8 times and has 8 different corresponding question twos. Isn't that what it would be?
That's what it does look like. So if you were to just put that question into the dictionary, what would it show you? What is your line above there?
Oh, that's the
dictionary thing?
printout of the dictionary. Yeah, just 3 values. So, I just wanted to see what the dict looked like, or some values in the dict.
Were you using like question 1 as the key there on the dictionary?
I was just slicing it by some number of entries in the dict. I wasn't using a key. You can see what I was doing here. Here. So all I was doing was saying, give me 3 items. Because qdict.items is iterable. So I can just slice that iterable and give me that 3 entries of it.
Yeah, so like in the function there, the Q1 frequency function. Yeah, so like there, the row question 1, that should give you like the actual text for question 1, shouldn't it, for each row?
Yes.
So you could use, just a sample question as the key for the dictionary to see what it gives you back. So for instance, you could do qdict with your second
the entire
question
string of that question. Yes, you're right.
Yeah, and see, do you get like 8 question 1s back?
Yeah, that's
but yeah, certainly for the numbers you're getting, that's what it sounds like it's doing.
Yeah, that's what it seems to be doing. But I'm just interested. I just thought it was fascinating, that they're trying to figure that out. And then, so that leads to this next question of what's the intersection doing, right? Because the intersection then means that it's qdict of this intersection with qdict row question 2, which means what entries are common, and what's the length of the common entries between question 1 dict and question 2 dict. Question 1 key and question 2 keys, right?
Yeah, I'm not entirely sure. So.
Yeah, again, I think Steve, I'll use next time the actual, like you suggested, put in the keys, so put in the actual entries of row question 1, intersection row question 2 for some values that I have already here. Because what I found fascinating was, if you look at, sorry for my scrolling inability, if you look at, we begin to see some intersections and some very significant intersections on the 18th row, for example, or even this guy or this guy, right? So if you have a lot of entries, which Q1 frequency does, and if you have a lot of entries for Q2 frequency, then it seems like, there's potential for the intersection to have some values in it. But what is most interesting to me is how the hell even somebody thought of doing this, or what drove them, or what kind of thinking is needed in order to say, oh, let me generate this data, because I would have never thought of this on my own. I mean, other features and stuff, yes, but there's no way I would have, or I haven't seen any, or the intuition behind, why would this, I mean, I can understand it gives you overlap of values and therefore gives a hint with respect to the duplicate, but it's still kind of not very clear of what is the intuition behind generating these features. Does anybody have any thoughts?
Thoughts, but maybe would it be possible to see one of those questions which has like Steve was saying, like just to see, we might get some ideas from there.
Yeah, unfortunately, I'd have to rerun my. Let me see whether I can just reconnect and print, because if I have to rerun the notebook, it's going to take a while.
Oh, I see.
Unfortunately, it disconnected because I was running it before, and then it took a while. If I can just run that cell and have the context saved, oh, it's reinitializing. Dang. So I think we're screwed. Let me just run it as is and see whether it works, because if not, then we'll have to do it. If it says blah that I can't figure out anything, then if not, I might get lucky. No, it doesn't recognize it. So I'll have to run the whole notebook in order. That takes a while. Not very long, but I don't want to keep people staring at screens. But yeah, that's the next thing, as Steve suggested, I can stick in actual sentence here for where I've seen the values to be interesting below. Oops, dang, I lost that too. Okay, I'll just redo that. But the data that existed here before gave me the numbers for when intersection was very high. So I can look at that, and then, as Steve mentioned, figure out what the entry is for that, what the entries are. But it seemed to kind of figure out, for lack of a better word, where the question itself is duplicated in the Q1 question column itself, and what are the corresponding entries in the dict are all the entries from Q2 that are for the same question in the Q1 column. That's what Q1 frequency and Q2 frequency are. That is, for a given question in Q1, how many Q2 questions are there which are distinct, which are, because it's a set after all. So in a long list of entries, it's like saying, oh, this question, this entry in question 1, or this question in question 1 has 8 corresponding non-common, meaning non-identical questions in the question 2 column, and vice versa for Q2 frequency.
So I have a question. When the problem is formulated, does it say anywhere that in the set the duplicate is there only once? So we're given a pair of questions and we're told it's a duplicate or not, but do we know that there are no other duplicate in the second column?
You mean multiple duplicates? Is that your question? Yeah, I don't know that. That's a good question. I can look at the EDAs that people have done to see whether that exists. It'd be fairly easy to check.
But because basically, if that's the case, that's an extra information. You can assume that you're matching questions, and if you have one match, like it's never going to happen again. So if you're confident that one match is good, then the second match shouldn't happen.
Yeah, but given your question is a good one, Yuri. I haven't looked at it, but I would tend to think that they being Quora, would not probably ensure that, right? Because there very well could be instances where questions could be duplicated multiple times. That is, people are asking the same question. But I don't know that for a fact whether they exist in the data set. That is worthy of checking. So I'll look into that. But in the real world, they're likely to exist, right? Because you would ask the same thing. And in fact, to a certain extent, this seems to kind of go after that, because it says, for my question one string, how many different question two strings am I getting? And that is useful in deciding, or that number is useful in deciding whether a question is a duplicate or not, because that's what Q1 and Q2 frequencies are.
So like one logic could be, well, if somebody asked this question twice, it was probably going to be asked third time and fourth time.
Yeah, something like that. That it's the probability of it. But I thought I just wanted to understand what this feature is and how somebody got to specifying it. So that's what I thought was interesting to pursue this, because it seems to help quite a bit, which means I wanted to understand what it is and what's the intuition behind it. So if anybody else has any thoughts or wants to do more or clarify or point out any mistakes in what I'm saying, please speak up.
Just on a separate note, I use a little bit of Stack Overflow as well, and in a Stack Overflow, as you mention your question, they actually recommend you the other similar question people have asked, and they are quite close to what you have typed in. So I'm not sure whether they're based on the based on only on a syntax or tags you're putting in, or whether it's based on your semantic as well. So they are using, I guess, this model of recognizing the duplicate questions over there in a Stack Overflow.
Any other comments or thoughts or intuition about this? Or how one would get to this point of thinking about it. Anyway, I just thought I wanted to, since I was using this, it would be important to understand, and I'm getting close, but I'll do what Steve suggested and figure out a little bit more. But at least it's clear of what Q1 and Q2 frequencies are. Still have to figure out. Intersection would just mean probably that what's the intersection between these two. But I am still struggling at how to a first vague order, I can understand how these numbers could contribute to helping, but it's still vague. And especially haven't figured out the intersect. So if somebody has thoughts, wants to play around with it and give us their opinions or inputs, most welcome. Okay, I'll stop sharing now. Any other questions or comments? On the one other thing I wanted to try, and I ran into some trouble, so I'll keep you folks posted, that I was thinking of based on what I saw in the LSTM and CNN was somehow combining the outputs or both those networks and seeing whether I get better results. And when I say combining, I actually mean generating the fields, not just doing prediction averaging or ensembling, but actually using the output and concatenating it and then sending it through a bunch of um, linear dropout batch norm kind of layers and getting the output and seeing how that works. So I'm beginning to play with that, but again, you're welcome to try that as well and see whether that gives any better results than what we have been able to come up with so far. Okay. Any questions or comments from anybody else?
I can share something that I saw on
Go
GitHub.
ahead. Go ahead.
Actually, I didn't go through it much, so I won't
That's
have too
fine.
much to speak, but I can share it.
Yeah.
You guys can see, right? Hello.
Yeah.
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 Okay.
Yeah. We can
Okay.
see.
Okay.
Go ahead. Sorry, I was muted.
So there was this paper called Enhanced Lstm for Natural Language Inference.
Hmm.
So this is for textual entailment tasks. I have not gone through this paper at all.
Yeah,
But
but
yeah,
sorry, NLI is this, does it follow or all that kind of stuff, right?
yeah,
Does it,
yeah,
does one statement imply the other or doesn't, or those kind of things?
yeah. Entailment, contradiction, and neutral, I think.
Okay.
So that kind of task. So this was, I think, kind of state of the art at that point of time. And so this model was used for the Cora task, and apparently it's one of the top solutions. It
Cool.
I'm not sure if
89.
this is among the best. Is it among the best?
I haven't, in fact, I wanted to also mention maybe I'll give it one more week and then after that compile as I usually do some of the top entries. So I haven't looked at it yet, Gautam, because I wanted us to
Okay.
struggle with things maybe a week or two more and then let's look at the best. So don't know the answer to your question. But I mean, 89 seems like a high accuracy percentage. So I wouldn't be surprised if it was.
Okay. So these guys implemented this paper on this task, and the model is it's similar in the starting aspects at least. So it has embeddings for both, and then it has let's go to the forward. It has word embeddings for both questions, and then it has an RNN for these questions, and then they have attention after that.
By the way, on that note, one question to use because the lengths show up here too.
Yeah.
So, what
Yeah,
did
I
you use as the
actually,
lengths?
in fact, I looked at this too. I mean, I was inspired by this. So lengths, I actually use them for. So there is this thing called pack padded sequence and pad packed. Yeah,
Right,
so
right.
that's just for efficiency. So if you have a padded sequence, you can like pack it so that unnecessary calculations are not done. So that all of those zeros are the matrix multiplications for those zeros
Okay,
are
okay,
not done. Yeah, it's
okay,
not
okay.
necessary, but it makes it
Yeah,
efficient.
yeah. So
When
you
I
can do
tried
a
it,
batch matrix multiply,
okay,
BMM
PMM.
type of stuff. Okay, but I get what you're saying. So you don't do the multiplication where it is padded.
Yeah. So if your tensors are packed, then it's more efficient when you do the multiplications. So I tried to do that and something got messed up, so I just removed it. So yeah, he has. In fact, I copied this thing as well. So he has. I think this is already there in TensorFlow, but it's not there in Python. So there's something called Rnn Dropout. This is a layer that he made and imported. And yeah, you guys can go through that. So I had copied this from this notebook and it improved my results a bit.
Yeah, there is in Torch in TensorFlow because
Dropout, right?
I'm setting it. Yeah, I'm setting it in the notebook. Yes, there are two values. I set them to the same, but there are two values.
Yeah. So this is just some dropout that you used right before your RNNs. Yeah, and he has implemented separate layers. I mean himself called first RNN, and then there's attention, and then concatenation and second RNN. Yeah, the model is a bit complicated, but it would be interesting for us to maybe look at the paper and also try to implement this. Yeah, and he has done it in Keras as well.
And that model is what he calls eSIM.
Yeah, this is what it looks like.
Cool.
Yeah, I just thought it might be interesting for us to implement this. Yeah, I'll share this in the chat.
Yeah, if you put the paper there, that'd be cool. Cool. That's an idea I didn't see before, so that's a good additional challenge to implement. Okay, thanks for that, Gautam. Okay, thanks everyone. Unless anybody has anything else, let's take one more week stab at the problem, and then maybe if we all agree after next week, then I'll see whether I can compile some of the top notebooks and begin to look at what's relevant from them. But let's frustrate ourselves for a week longer. Okay, thanks everybody. Thanks for joining. See you all next week.